Hello everyone. Let's now work on the practice questions for the final exam together. So again, for final exam, we have chapters 1 through 8. Let's look at question 1. So given x follows normal, mean 3, variance 25, what is probability that x fall below 3, right? So we can draw a standard normal curve. The mean is 3. So fall below 3, that's actually the left half, right? So that's gonna be 50%. So that's the correct answer. Question 2. Given probability of A equals 0.2, probability B equals point B, A, B independent, what is probability A and B, A given B, and A or B, right? Because they're independent, so probability of A and B equals probability of A times probability of B. So which is 0.2 times 0.8, so 0.16. That's probability A and B. Probability of A given B, the condition doesn't matter because of the independency. So that's just probability of A. So that is 0.2. Probability of A or B. So we have a formula which is always true. So we can write it down. Probability of A plus probability of B minus probability of A and B. So we have everything, right? Plug in 0.2 plus 0.8 minus 0.16. So that gives us 0.84. So that's probability of A or B. That's our question 2. Let's take a look at question 3. A medical trial into the effectiveness of new medication was carried out. 150 females and 100 males took part in the trial. So altogether, we have 250 individuals. So that's the grand total. Out of those people, 80 females and 60 males responded positively to the medication given below is a contingency table with the given information filled in. So we can fill in the rest, right? The marginal total for positive altogether 140. So then we should have 110 for negative. Because 150 total female, so this should be 70, and then 100 minus 60, so 40. 70 plus 40, which is again 110. So we verified, we calculate everything correctly. So let A be the event of female, B be the event of positively, right? So probability the select individual is a female, so that's probability of A, right? Female 50 over 250, right? So which is 0.6. And find the probability that select individual respond positively to the medication. So that's probability of B, right? So positively we have 140 total, right, over a marginal total over the grand total, right? So 0.52. 56. 0.56. And then find the probability that the select individual responds positively and is a female, right? So that's probability of A and B, right? So A and B, we have to find the count positively and female. So we have 80, right, over the grand total to 50. So 0.32. And then either or, so that's probability of A or B. So that is again probability of A plus probability of B minus probability of A and B. So we have 0.6 plus 0.56 minus 0.32. And then we put in to the calculator. So we have 0.84. And then E, and given the select individual is a male, so male means A complement. So condition on A complement, we want the probability of what? Negatively, right? Negatively is actually B complement. All right, so using the formula, that's product of A complement and B complement over product of A complement, right? So for the end, we just need to find the count, right? Male, negative, we have 40, right? So that's 40 over the grand total. That gives us a product of A complement and B complement. So that divided by product of A complement. So that's just 1 minus product of A, right? So 1 minus 0.6. So what we have is 0.16 over 0.4. So that is 0.4. Or we just use the definition, right? So definition is condition on male and the response negative. Condition on male negative, so 40 over 100, right? So we use 40 over 100. So that also gives us 0.4. All right, that's all for question 3. Let's take a look at question 4. Given the discrete distribution of a random variable y below, find the mean, variance, and standard deviation. So but here there's one probability we don't have, but altogether we have sum equals 1, right? So here is 1 minus 0.3 plus 0.5, so 0.2. So we fill that in first and then look at the mean, right? Mu of x, expected value of x, is sum of x times product of x. So right here, of course, we use y, but just a notation representation. So we're gonna use the number times the probability, right? And then keep doing it. Number 3 times the corresponding probability plus 5 times 0.2. So that's 0.6 plus 1.5 plus 1. So there's 3.1, right? So the mean is 3.1. Expected value of x squared minus mean of x squared. That's gonna give us the variance, right? So x squared. So 2 squared times 0.3 plus 3 squared times 0.5 plus 5 squared times 0.2. Right, that minus mean, which is 3.1 squared. So what we have is 4 times 0.3 plus 9 times 0.5 plus 25 times 0.2. So that gives us 10.7 minus 3.1 squared. 1.09, that's the variance, right? So standard deviation of x is square root of the variance. So that is 1.044. So we got the standard deviation as well. So that's for a discrete distribution problem. All right, question 5. 9 students were surveyed for how many times a day they check their emails. The responses were recorded below. So n equals 9, right? 9 numbers. We want to find 99% confidence interval for the true average email checking time and interpret it. So what do we have? We just have data, right? So we have to calculate x bar, which is sum of x over n. So that's 20 plus 13 plus plus the last one, 25, and then over 9, right? So we're going to use calculator to get this calculated. So 20, 13, 19, 19, 27, 22, 15, 29, 25. So we type in the 9 numbers, and then we add everything together. So we have 189 divided by 9. So that gives us 21. So the x bar is 21. And standard deviation, right? So we need a standard deviation because this is a sigma unknown question, right? So as is sum of x squared minus sum of x squared over n minus 1. That's the sample variance. Let's start from there. So sum of x squared is actually 20 squared plus 13 squared plus dot 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 plus the last one, 25 squared, right? Minus sum of x squared. So sum of x is 189 squared over 9. The whole thing, the difference, right, over 9 minus 1. All right, so what is sum of x squared? So let's type 20 squared plus 13 squared plus dot 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 plus 25 squared, everything into the calculator. And then we're going to calculate sum of x squared. So that's actually 4195. And then minus 189 squared over 9 over 8. So 4195 minus 189 times 189 divided by 9. So the difference is 226. So over 8. What we have is 28.25. That's the variance. So standard deviation S is square root of 28.25. That gives us 5.3151. So that's the standard deviation, right? So then we don't have enough space, so let's just do it here. Okay, so we're gonna write down the formula: x bar plus or minus t sub alpha over 2 with df equals n minus 1. So this check what? So 99% with df is 8, right? So check those two, and then times s, which is 5.3. Let's write down the formula first. So s over square root of n. And then s is 5.3151, and n is 9, right? So we have everything. So the t critical value, let's check the t table. 99%, 8. So t table is here. So 99% is this column is 8. So 3.355. All right. So x bar is 21. So what we have is 21 plus or minus 3.355 times 5.3151 over square root 9 is 3, right? So margin of error E is 3.355 times 5.3151 over 3. So that gives us 5.9441, right? So we have 21 minus that to 21 plus that. Okay, so 21 minus 5.9441, so 15.0559 to 26.9441. So that's the 99% confidence interval. Question number 6. 9 students were surveyed, and if someone claimed that the average email checking time is more than 18, so same data, right? So now we want to do hypothesis testing. So if someone claims that average email checking time is more than 18, want to test the claim, right? So step 1, the null and alternative hypothesis. So null is mu equals 18, and alternative is mu more than 18, right? Step 2, want to calculate the critical value, right? So because we have more than, so it's one-tailed, so t sub alpha with df equals 8, right? N minus 1. So alpha is 0.01, right? Because 99%. same data. So let's just use that 0.01, right? So 0.018. So let's see what it is. 0.018. So 0.01 is here, right? It was 8. So that's 2.896. Okay. So step 3, we calculate the test statistics. So this is a t because sigma unknown, right? So x bar minus mu naught, which is 18 over s over square root of n. So what we have is x bar 21 minus mu naught 18 over s 5.3151 over square root of 9. So that's 3 divided by open parentheses 5.3151 divided by 3 close parentheses. So that's 1.6933. That's test statistics. So step 4, we're gonna make decision, right? So we're gonna say reject H naught if TS, which is 1.6933, test statistic is greater than 2.896, which is not true. So fail to reject. So step 5, there is not enough. There's not enough evidence to conclude the average email checking time is more than 18 at alpha equals 0.01. So that's the conclusion. All right, let's look at the other question. Differ from 20, right? So step 1, null mu equals 20. Alternative mu is not 20. So this is a two-tailed test, right? Step 2 does not equal. So we look at the critical value plus or minus t sub alpha over 2. This df equals 8, right? So that's plus or minus t sub 0.005, right? 0.01 divided by 2 is 8. So let's check that. 0.058. 005 is here. Is 8. 3.355. All right. So then we're gonna do step 3. Our test statistics. Nothing changed, right? Nothing changed. Oh, the hypothesis value changed, so we have to do that again. Test statistic for t, x bar minus mu naught over s over square root of n. So x bar is 21 minus mu naught is not 20, right? Over 5.3151 over square root of 9. So that's actually 1 over 5.315 over 3. So that's going to give us 0.5644. Step 4, decision, right? Reject H naught if our TS is 0.5666. It's greater than 3.355. It's positive minus for the critical value. We only take the positive value because the test this is a positive value, so we just need to compare that side. Is not greater than, so fail to reject. Fail to reject. So step 5, there is not enough evidence to conclude average email checking times is differ from 20 at alpha equals 0.01. All right, that's the question 6. This is testing. Question 7, from the 95th percentile from a normal distribution with mean 10, variance 4. So x follows normal. It's 10, 2 squared, right? Standard deviation is 2 because the variance is 4. Right, 2 squared. And then we want to find P95. So probability of x smaller than P95, right, equals 0.95. So transfer to z, right? That is probability of z smaller than P95 minus mean over standard deviation, right? Equals 0.95. So we check the table, right? 0.95 backwards. 0.95. We need a standard normal table. Where's 0.95? Right here, right? 0.95. So 1.645. 1.645. So that's backwards reading, right? 1.645. And that is P95 minus 10 over 2. So we have our P95 equals 1.645 times 2 plus 10. That is 13.29. 13.29. All right, question 8. Yeah. Question 8 is actually a repeat, right? It's a repeat. So we did that already. 20, 30, yeah. So question 9, given x follows binomial 10.6 from the followings, right? N equals 10, and little p is 0.6, right? Probability of x equals 5. So we need the binomial distribution table. So distribution table, we need, what's that again? N equals 10, p equals 0.6. N equals 10, p equals 0.6. So 0.6 is right here. N equals 10, right? And then we want a probability of x equals 5. So this is the value, 0.201. Right, from the binomial table. So for strictly equals, you can calculate. Right, that's n choose x, 10 choose 5, p to the power of 5, 1 minus p, which is 1 minus 0.6, 0.4 to the power of n minus 5. 10 minus 5 is still 5. So 10 choose 5. $252 times 0.6 to the 5 times 0.4 to the 5. So we use calculator. And that's 0.20, 0.2007. So which is 0.201. Probability of x more than or equals 2, right? So 2, 3, 4, up to 10, all add together. So that's the same as 1 minus probably the ones you don't want. Smaller than or equals 1. So check the cumulative table, smaller than or equals 1, right? So find a binomial cumulative table. N equals 10, right? Probability 0.6. So this column, right? And then 1.002. 0.998. And then expected value is n times p, so 10 times 0.6, so that's 6. Variance n times p times 1 minus p, 10 times 0.6 times 0.4, so 2.4. That's our binomial question. Question 9. Our last question for this practice exam. The weight of a type of dog follows normal distribution. So x follows normal, which means 10, and standard deviation 4 pounds. So we're getting 4 squared. That's the variance. So probability of x less than 8 pounds, right? So that's probability of z smaller than 8 minus 10 over 4. So that's probability of z smaller than negative 0.5. So we check the normal table. Negative site, 0.5, 0 is right here, 0.3085. Okay, we're done with that. What's the probability of dog of this type will weigh more than 14 pounds? Probability of x more than 14, which is probability of z more than 14 minus 10 over 4. So that's probability of z more than 1. That's 1 minus probability of z smaller than 1.00, right? So we check the table. 1.00, 0.8413. Don't forget there's a 1 minus in front, right? So 0.1587. That's the answer. What is the probability of a dog this type will weigh between 6 and 14? So probability of 6 smaller than x smaller than 14. So that is probability of 6 minus 10 over 4 smaller than z smaller than 14 minus 10 over 4. So that's probability of negative 1 to smaller than z smaller than 1, right? So that's probability of z smaller than 1 minus probability of z smaller than negative 1. Smaller than 1, we check it, 0.8413. Smaller than negative 1, so we need to check negative 1. So negative 1 gives us 0.1587. So we look at the difference. 0.6826. And the 90th percentile, right? 90th percentile. Probability of x smaller than p90 equals 0.9. So that is probability of z smaller than p90 minus 10 over 4, which is 0.9. So we check 0.9 backwards, right? 0.9 is between those two, right? 0.9. So that's 1.285. 1.285. So what is 1.285? P90 minus 10 over 4, right? So P90 is 1.285 times 4 plus 10. So that is 15.14. That's the 90th percentile. Okay, last question, part E. Find the probability that the mean weight, average weight of 25 random selected dogs. So that's n, right? Equals 25. And between 9 and 12, right? So that's probability of 9 smaller than x bar, because this is the mean weight. So we look at the sampling distribution. So x bar follows what? Follows a normal distribution with the mean, right? Original mean, but the sigma changed, right? Sigma over square root of n, that's the new standard deviation, right? So mu is still 10, but the standard deviation is sigma, which is 4 over square root of 25, which is 4 over 5. So 0.8 is the new standard deviation. So now we standardize it. Probability of 9 minus 10 over 0.8, smaller than z, smaller than 12 minus 10 over 0.8. We have an updated standard deviation. So that's -1 over 0.8. So -1.25, smaller than z, smaller than 2 over 0.8, which is 2.5. That's probability of z smaller than 2.5 minus probability of z smaller than -1.25. We check 2.5, -1.25. So 2.5 first, 0.9938. -1.25. -1.2 right here. 2, 2, 1, 2, 2, 2, 3, 2, 5. 2, 5 is right here. 1, 2, 3, 4, 5. So 0.1056. So take the difference. That's 8882. All right, that's all of the questions. Again, this final exam will be comprehensive, so not limited to questions in the example test. So everything from chapters 1 through 8. All right, thanks for watching.